Everyone, kindly settle down and let's wait a few more minutes for the rest of the folks to join in, and then we'll quickly get started with this meetup. Till then, you all can all scan the QR and join our talent community. So we'll take a 2 to 3 more minutes to start. So till then, what I'm gonna do is go around and ask y'all things that y'all are pretty uncomfortable with. Just who you are, introduce yourselves, and what are you looking forward to today. So I'm just gonna go randomly. Uh, People on phone.
Is this okay? Hello. So my name is Kushbu. I'm working in DXC Technologies, and yeah, like I have some experience of around 6+ years in iOS development. So yeah, I am just like looking for this conference, like what and all will you like the more knowledge I'll be gaining today, and yeah, using that in my future. So all these things I'll be looking forward to. Thank you.
Thank you, Khushbu, for that wonderful introduction. And sorry if I made you awkward. I'm gonna pick another person on the phone.
Hey, okay, my name is Rhythm, and I have been an iOS developer since 2 years now. I'm currently working in a fintech company called Jar. It goes by the name Change Jar, and I'm looking forward in learning new technologies around the same iOS development, and maybe return back to like the future upcoming people into this industry. So that's it. Thanks.
That's nice to hear. Anyone else who would like to go voluntarily? Okay, that's enough.
Hello everyone. My name is MD Inzamamul Haq, too long of a name. You can call me Inzi in short. I'm a fresh graduate. I just started interning as in Global Logic. Apart from that, into iOS development, I got introduced by my college, and we did a kind of project in collaboration with Infosys and Apple. So that's how I got introduced to this. But looking forward to this meetup and to know fellow developers from this field, because you all know that this field it's tricky here and there. We'll discuss if anyone would like to connect. Would love to do that. And also, this is my first day in Bangalore, and I just got scammed.
Do you want to share what happened?
Oh, actually, but okay. I mean, it was not that miserable, but then yeah, in terms of cost, basically took a auto from Brookfield to here, and we had a very nice conversation, and I paid 600 rupees. So
Uh-oh. Okay, so without much further ado, we'll start with this meetup. And yes, there's networking and all. You all can connect with each other and make this community stronger. And yeah, so a very warm welcome to all of y'all, all the iOS enthusiasts here at the mobile meetup at Intuit India, powered by TCC, Tech Culture's champion community. I'm Ishika, and I'm a software engineer at Intuit. I'm in QBO Advance, and I'm your guide here today for this tech adventure. We're excited to bring to you a first in the series of a mobile meetup, like mobile community meetups by Intuit. So, what we're planning to do with this meetup is we're trying to foster a community of niche iOS developers. We want to establish Intuit's role as a sorry, Intuit's role as a thought leader in the mobile space and enable them to learn from peers, seek interesting conversations, and ultimately create a cohesive environment and an ecosystem for the top mobile dev talent across India. We've got a star-studded lineup today of speakers and sessions that I promise you to take on a new journey of thrilling adventure and to the latest trends of mobile dev and Gen AI and AI and ML in iOS. To get the ball rolling, let's welcome on stage Akashlal from Intuit. Akashlal joined Intuit as an iOS developer a couple of years ago and is building platform solutions solving customer problems at scale with the best of mobile tech. Apart from work, he helps developer communities like Swift Bengaluru and is interested in startups and growth marketing. Akashlal, the stage is all yours, and welcome the iOS community here.
Thank you, Shika, for passing on the mic to me. Thank you for taking time and coming here in person in this busy Tuesday. I know it's a working day and it must have been busy. I'm so stoked to see a houseful audience, and I'm pretty sure that this will be a really good use of time. You won't regret this. With that in mind, I'd like you to tell you some things about Intuit. We are powering prosperity around the world. We are a global technology financial platform. We have been in the market for over 40 years now. We have seen everything, and by everything, I mean everything. We have built solutions on DOS and desktop, and then we moved on to web and mobile, and now we are preparing ourselves for an AI era. We are we directly employ over 18,000 people and help over 100 million customers reach their financial goals. We have been active operational in over 9 countries, with India as our primary growth site, and we are looking to hire more because it's a growth site, and we are looking to hire top devs like you. And yeah, what we do at Intuit. We have four product lines. One is Intuit QuickBooks, where we help customers, small businesses, with their daily business needs. We have TurboTax, where we help people with filing their taxes using software. We have Intuit Credit Karma, where we help people manage and improve their credit line. And lastly, we also have MailChimp, where we help businesses go to market. We do great work at Intuit, and it shows. We have been recognized as one of India's leading companies by Great Place to Work, Best Places for Women to Work. Globally, we are also recognized by Fortune, People's Magazine, and much more. The mobile ecosystem at Intuit is diverse. We have a platform team that builds common platform features. We also have product teams that build actual apps that people, our customers, use. Our ecosystem has been growing year over year, and we are building a strong mobile center of excellence in here, so that we can look at ways to create and innovate for our customers. We also believe in giving back to our community. Uh, we have a group called Tech Culture Community Champions at Intuit, which were again founded by Intuit employees and are also run by Intuit employees. So that is one group that has also helped us organize this within Intuit, along with Swift Bengaluru, which is an external iOS dev centric community. Sorry. Here at Intuit, we embrace a day one mindset. We are curious about what's happening outside in the world and preparing ourselves for it. We believe that AI is going to change the way people do everything. And at Intuit, we are doing two things on two fronts. One, we are helping customers solve their problems easier with AI. And for developers, we are looking at how we can improve developer productivity, help them build better code, and build it at scale. When Swift Bengaluru came to us with an AI centric agenda, we thought it would be a great opportunity to come together, learn, and see what others are doing in the space when it comes to AI. So I hope you have all come with your questions, and we leave with our learnings. Coming to the agenda, we have Wasim from Intuit, who will be talking on how Intuit is using Gen AI to build no code based pages for both Android and iOS platforms. Then we have Swapnil Do, who is coming from Loyalty Juggernaut. He'll be giving us a primer on ML in iOS, on Apple's ML frameworks. He'll also show us how to build, validate, and test and create a ML model, and also use it in our iOS app. I found it to be pretty exciting. And lastly, we also have Pawan from Code and Theory. He'll be showing us how he uses AI to build Xcode extensions, and improve developer productivity. So yeah, that's all. With that in mind, I hope this would be a good, insightful session for all of you. I'd like to call back Ashika on stage and let her continue with the hosting. Thank you.
Thank you, Akashlal, for that electrifying start. Now I would like to call Wasim Sayed, who will join us virtually to begin with our first session on Intuit's Gen AI mobile technology and patterns, streamlining processes with ease. Wasim, a little introduction about Wasim. Wasim is a senior staff software engineer at Intuit and a mobile architect with over 17 years of experience in full stack software development, specializing in mobile for several years. He has a unique experience of building mobile apps for different industries, including fintech, retail, real estate, and online marketplaces, and much more. As a lead developer for mobile platform team at Intuit, Wasim spearheaded efforts in developing several Gen AI powered mobile experiences. He's a passionate technologist who shares his knowledge in mobile architecture through blogs, webinars, patented innovations, reflecting his commitment to technology and his community. In his free time, Wasim enjoys traveling and playing cricket. Wasim is based in Mountain View, California. Over to you, Wasim.
All right, thank you for the intro, Ishika. Let me take over the screen share. Are you able to see my screen? I take that as yes. All right,
Yeah,
hi
we
everyone.
can see it.
Sure. It's an honor and pleasure to be among so many talented people today. My name is Wasim Syed, and I'm gonna present to you on a topic, Gen AI mobile technology and patterns and how they streamline the processes with ease. I'm gonna skip my intro slide because Ishika has done a better job than me. A quick disclaimer note. So please note that this presentation is intended as a general overview of Apple's frameworks and other general development patterns can be leveraged for developing Gen AI experiences on mobile and does not represent any specific use cases of Intuit. So here's the agenda for today. We're going to talk about the Gen AI mobile platform and some of the building blocks and concepts like renderers and experiences, multimodality input, actions framework, and derived context. So what is a Gen AI mobile platform and why are they important? So Gen AI mobile platform is a set of pre-built foundational elements and modules such as chat widgets, UI components, reusable experiences, which could be used to quickly build and deploy AI experiences across the board. So the developers can ensure they have consistent user experiences across devices and apps, greatly reducing the time and effort needed to build and develop and maintain multiple applications. So this is particularly critical in a large scale organization where there are multiple apps and sometimes multiple development teams. And when you have an AI experience that you're building on mobile, you don't want them to look, disjointed across different apps or sometimes within the same app. So the platform's efficient development process, it helps you avoid code duplication. It enables the developers to run faster so that they could just focus on creating innovative solutions, on AI rather than spending time on writing code for problems that were already solved by other developers many times in the past. So the platform also provides out-of-the-box tooling and feedback loops, enabling the developers to seamlessly integrate analytics and customer feedback so that you learn continuously from your user engagement and feedback from your customers. So the motto here is you build once and reuse everywhere. Renderers is one of the foundational elements which help you specify the format in which you want to receive the GenAI responses in. Fuego response format, commonly known as FRF, is a server-side driven UI and navigation solution that lets you use the same DSL across multiple platforms, iOS, Android, and web. It enables you to quickly release features on all platforms with just simple content deployment changes on the backend. So the native player, which is an open source library built by Intuit, it parses the DSL and identifies the assets needed for rendering these the DSL. So it also chains multiple pages together. You could think of it sort of like a linked list of pages where you have nodes for and references for the next item, next screen in your screen in your current screen. And this enables for a server-side driven navigation. So player works effortlessly with your existing UI components and design systems. So native player assets, which are nothing but the UI components that you build on the front end, they implement the FRF contract in a way that your designers have envisioned. So you could always have a design system that is specific to your app or a theme that you want to have, and your assets would simply blend into your app, making it look seamless. So the library offers a wide range of optional plugins that help you essentially unlock many functionalities like embedded beaconing, action handling, pubs up, and regular expression. For example, if you have embedded beaconing plugin, so it's essentially like if you want to log any analytics for your clickstream, or if you want to have an action handling, if you have items that demand you to like tap on them and handle a certain action, this library offers a wide range of plugins which will unlock the functionality, and it's a full-fledged tool that you want to that comes pretty handy for any server-side driven development. Now let's take a look at how this all works. So the content is written in the form of a JSON called FRF, which is a representation of a UI and data. It will have the information like the type of the UI element, the value that it needs to display, and the action that it warrants to be taken on. The player asset is an implementation of an FRF object that interprets the JSON into an UI element. And the player library traverses deeper into all the nodes of a JSON and finds the appropriate assets that will help render each of these objects. So the final result would be the UI successfully result, which can honor any app theme depending upon the configuration. And the library provides a number of built-in player UI asset plugins, which can render majority of the UI elements. However, if the customer has a specific need where they would like to inject their own player asset plugins, there are APIs to do that as well. And this is an open source library, and it's available out there to check it out. Markdown is another form of rendering. It's not something new, but I think it does a fine job in highlighting key pieces of information. So the clients could specify the responses from the LLMs to be written in the form of a markdown, highlighting the key information. And the in-house libraries for markdown, they respect the semantic rules of the markdown and render accordingly. And this form of rendering helps structure the data in the form of like headings, lists, tables, bullet points, all the semantics of a markdown. So it also improves readability by highlighting the key information. So in this example, as you could see, you could easily pick up the dollar amounts, the things that you want to highlight to the user. The other form of render supported include JSON. So here we just say JSON, but the clients could define their own schema for the response that is suited to build their data models for business logic, or even define their own DSL if they have a different rendering mechanism, or if they have a like a different server-side driven UI mechanism. So in the embedded web format, the generated AI curated content uses responsive web, all the web technologies like HTML, CSS, JavaScript, exposed via an authenticated API that the iOS clients could leverage to render content within a WebKit on mobile. Although it's not mobile first, it offers a bunch of benefits. The infrastructure that is built for web application helps you helps you leverage it for mobile, and you could deploy the experiences much faster in production, and it works pretty well for many of your use cases. What are some of the experiences that could be built with the elements that we have discussed so far? So assistive chat is one common experience in GenAI. We've all seen chat experiences powered through GenAI. So the chat library that we want to build through assistive chat requires the developers to go through following steps. So they invoke the chat library, which provides the out-of-the-box player assets that we discussed so far, and the built-in UI elements, and also integrations with LLMs, preserving the context and the conversation history. So they let you select the format in which the content is expected to be. And it also lets you configure the GPT models that you want to connect to. Some models are quite accurate, some models are faster. So it lets you, choose an option depending upon the model that you would like to connect to. And it also lets you register the custom renderers or asset plugins, and you can inject the app themes that we discussed so far. And the chat library would also have configurations to support various use cases that you might have in your business. So we're going to take a look at a simple demo. It's a sample app. Essentially, what we're doing here is, we're just showing you a chat application where the user would like to ask a question that goes something on the lines of, how do I manage my expenses better? And the response that you get is the key. So essentially, the response that you're seeing in here, the pills that are displayed in green and the buttons and stuff, these are all rendered using the server-side driven UI that we talked about. So there's a JSON DSL that represents this data that you're seeing on the screen, and we will have the assets that essentially parse this data and kind of show it on the screen. So as many assets that you have, which comes through the foundational elements of the player library, it has a possibility of rendering any kind of information. The other experience that we would like to talk about is the personalized embedded summary, which are non-chat based experiences that could be enabled in different places in the app. So these embedded summaries, they provide a context-based summarization of data and provide key insights for the users in an itemized statements and graphs. So for example, when the user taps on a banner for embedded summary, a prompt is sent to LLM along with the data model that is in the current context, and the insights are generated using the data that is provided. So the product owners can actually go, or even the engineers can actually go iteratively configure the query prompts on the backend to ensure that the experiences are enhanced over the period of time and the insights are impactful. So one thing to keep in mind in these kind of summaries is that as much as the users want to get the insights, they also would not like to get the unwanted insights. So it's pretty important to to understand what is being served to the user, and the feedback loop definitely comes in pretty handy there. So for example, you see an sample application in here which has a banner that says generate an AI powered overview. And when the user taps on it, it shows a bunch of sections in which there are insights on. You see three sections so far related to profits, essentially profit and loss, vendors, and invoices. The user could choose to select and unselect the insights or the areas of insight that they would be interested on, and the user could always add more insights by clicking on generate. So when the cash flow is added through generate more insights, it adds a new option up there. And at the end of the day, like when the user is done configuring the insights and clicks on the save button, we would know in the backend, on what areas the user is interested in and what areas the user is do not want to see the insights. So even though the UI is simple here, you could have anything ranging from things like frequently asked questions, or like or you can even show them areas that you would like them to highlight on and stuff like that. The takeaway from here is the feedback loop, where you're constantly engaging with the user in a non-chat based experience to kind of get their user preferences. So multimodality is another aspect that we're going to talk about today. It captures a diverse sensory input from user for an improved natural interaction. So the voice to text conversion library provides an inbuilt logic that standardizes the UI that could be used by developers to enable speech input for GenAI experiences. The library uses Apple's AV Foundation framework to capture and process the audio, and the speech framework to convert the audio into text. So the library leverages the Apple's real-time and batch subscriptions, meaning it can recognize, as it's being spoken, as well as once the speaking is fully complete. The out-of-the-box analytics tooling and feedback mechanism ensures that the user engagement and feedback is captured which helps us learn and improve the experiences in the future. And the other aspect of multimodality is, another paradigm is the image. Image input is another form in which the text is extracted from an uploaded image. The images could be anything ranging from your invoices or receipts or handwritten notes, etc. The library, using the Apple's Vision framework for image recognition and text extraction, it provides APIs for configuration of things like, your locale or set the accuracy levels, and also a choice of usage of whether you want to use the on-device ML or you want to send your text to processing to AI LLMs. As per Apple, in all cases of vision processing, it happens on the device. So, the if it is on device, it's expected to enhance the performance, and it is expected to protect user privacy as well. Raw text could be, text input from sources like email, tasks, addresses, etc. And how does this all come to play? Let's take a quick look at the demo right here. I'm going to keep quiet for a little bit because, you're going to hear an audio with a prompt from the user.
Go for a walk later today. I also need to walk Riley for 2 miles around the park later.
So the user has, recorded a message, and it looks something on the lines of "Go for a walk today and walk the dog." And if it's sent to the LLMs for processing, the LLMs responded to you saying that they found a task in the notes, and and it gives a prompt saying if you're interested to continue or you would like to dismiss. So I hit continue to, and it automatically, launches the UI that is necessary to, for the task creation. And the user has a choice to obviously, overwrite some of this information, but this essentially reduces the number of steps for the user. And similarly, there are other modes of input we could see from image, where the user could actually upload an image, which is a handwritten note that looks, that has something on the lines of "after the work is complete, send finalized invoice to so and so." And with that, we actually extract the text from the image, and when it's sent to LLMs for processing, the LLMs have responded saying that they found an email draft in the notes, and asking for a permission to the user, if they wish to continue. And if the user wishes to continue and create an email, it automatically creates an email with a recipient name, subject, and body. So a lot of fields that are pre-populated. So body has, it already has a context on what the user would like to do, and the user could always add more to it, or edit the reminder of the body, and they could send a email. So it basically generates an action within with all the steps pre-populated. And finally, text input. It's a simple text. The text could get quite complicated, but here's a simple example where you have a name and a number, and it apparently detects a contact card for you to as an action. And how does this all work?
Go for a walk later today.
Is through the actions framework, which is essentially a segue from the multimodality input. It's a library that takes the text from any input source like voice, image, emails, and converts them into actions. The clients could configure the library with a list of supporting actions. Prompt Manager hosts the query on the backend. It also applies a set of moderation rules before the prompt is passed to the LLMs. So the Prompt Manager, filters any cuss words or anything that triggers a flag before it's sends to the LLMs. In case of the Prompt Manager, sometimes you might need more context. So the prompt manager in that case could also fetch data from the backend systems and include that as part of the query. The actions framework passes the response from the LLMs back to the map actions and orchestrates actions like creating an invoice, drafting an email, or creating a task, and so on and so forth. This is just a pictorial representation of everything that we discussed so far. Multimodality inputs on your left could be captured via various modes. A user can either record a voice command, upload an image, or type something, and these libraries convert the input into raw text. The app or the library developers use the actions framework library APIs to configure the text with a list of supporting actions to their business. And this process is particularly efficient as the input raw text could vary. For instance, a text saying play soccer might not be associated with any of your business and may not trigger any UI action. So it's important that you have those supported actions. And once the actions are curated, the actions framework converts it into a JSON format along with the raw text and sends it over to the prompt manager. The prompt manager hosts a query, supplements the actions with the raw text, and sends it over to the LLMs. Hosting the query on the prompt manager helps you update the query as we learn from user feedback and engagement without going through an app store or publish. And the LLMs classify the text and try to detect any matches to the provided JSON, thus returning a list of match actions with pre-populated data models. Finally, the actions framework, it orchestrates the callbacks and launches the associated sequence of UI and pre-populated data, and thereby reducing the steps for the users. And here is just a template of how the AI actions are created. An action is expected to have action name that signifies the type like invoice or contact card, etc. Each of these actions have their own data models. For example, an email action could have fields like recipient name, subject, body, whereas the invoice action would have properties like invoice ID, items list, and total amount, and so on and so forth. And here is an example of the prompt versus the output captured from a GenAI tool. The raw text that is passed here is Freddie, a number, and the text that goes on the lines of grocery tomorrow. The supported actions passed to this include a contact card, email, and a task. And as you could see, the LLMs were able to extract the data and identify the matches with contact card and task action, and they are also populating the fields which are extracted from the raw text. So the actions framework library, when orchestrating these actions, it ensures that these pre-populated fields are shown on the UI. The next concept that we're going to talk about today is the derived context. Derived context is essentially an inferred context or a prompt in case when there are no explicit prompts received from the user. Descriptors are one of the strategies for inferring the context where there is no explicit prompt provided by the user, like in a chat-based experience. Descriptors use a combination of static description and dynamic values. A static description provides information that help the LLMs understand the complete description of a UI element, its importance, and its preferred usage in terms of data classification. So the descriptors, the description could be hosted on the client side or fetched from a remote config source, or could be part of your own data models. So in this example, the description is for a screen, and it describes a screen as something that provides a real-time snapshot of the available stock of items. It's critical for decision-making process and helps business stay efficient and customer friendly. So it's a description of a screen, an example of it. Dynamic values are essentially the data fetched from your network calls, which provide more context and clarity to the screen in contention. Descriptors could be at any level. They could be defined for a screen, a section of a screen, or for a property on a screen. In this example, query is generated by some intent, which is to essentially generate the insights to help me understand the state of my business. And the intent uses the description of each of these screens. In this case, it's the inventory, expenses, and revenues. And we are also supplying the associated properties of it. So, this is through a markdown rendering, asking the LLMs to highlight the key information. So the response is a summarization and categorization of key areas of focus, things that the business owner should be paying attention to, and the areas that are performing better. For example, in this case, the user's business apparently is run in a profitable state with the revenues increased by 30% and the operating costs are decreased by 10%. So the business is doing great apparently. And the user needs to still pay attention to some of the critical items, things like low inventory and the areas of spending. So this just gives a quick snapshot of the state of the business and the revenues. So adaptive content management is another process in which the content could be managed efficiently to create adaptive screens on the fly. So it's an approach again in the derived context, which helps you construct insights by assembling parts of various screens based on the suggestions from the LLMs. So in a server-side driven UI, like FRF rendering, for example, the one that we just discussed in our previous slides, each screen is a representation of a JSON, a set of JSON objects of individual UI elements, like rows, for example, or rows in a list, or list in a section, or section in a screen. As network calls are made, when the user navigates to different screens, the consolidated responses are sent to LLMs where certain policies are, when certain policies are met, the responses are sent to LLMs when there are certain policies that are met. And these policies could be defined by the product owners based on factors like user entitlements or navigation patterns or frequently visited screens, or they could even set limit on the number of tokens that you wanna send to the LLMs. For example, if the user is navigating to screens like orders, inventory, and expenses at the close of business for that day, it could be quite possible that the user is trying to understand the state of the business on that day. So the LLMs return a map of screen names and the properties with a level of priority attached to them. The final output would be a JSON with consolidated objects mapped against each screen and ordered in terms of priority higher to lower. The server actually sends the response proactively to the subscribed clients over a stream using protocols like RSocket or HTTP2 or gRPC, and the content is rendered on the front end. So here, these are more proactive experiences because you're not waiting until the client, until the user clicks on some button or fetching the information. You're essentially giving a nudge to the user that, hey, there are insights available for you if you would like to take a look. It serves the stream on an open connection through some of these protocols that we mentioned in here. And here's a simple query of how this would all work. So the query would say, return the items that need my attention with screen name as key and items as value using the following data. And the LLM response is expected to be, things like the order screen with the items that are, the things that are important in each screen. Apparently, total number of orders is the one that sounds to be, the critical one. And in the expenses screen, most expensive material, and in the inventory screen, the expiring ingredients. So depending upon the data and depending upon the criticality of the data, the LLMs would respond, and you would know essentially what property to be displayed on a particular screen in your summarization. Now let's take a quick look at the demo. This is again a sample app, which kind of replicates a sort of like a small business application. So here's my business where I'm actually essentially going from one screen to the other. I clicked on the inventory screen, and then I go back and I click on the order screen. I just want to, an order screen, as you could see, is a catalog of orders, and there are other items with things like total revenue generated, total number of items, and orders placed, and so on and so forth. And the user navigate to different screens, and the user is on expense screen. And I see an insight that automatically popped up as I've been navigating between different screens. And this is an insight that is essentially sent from the server. So basically, depending upon my navigation pattern and my user entitlement and some of the policies that are met, so there's an insight that is generated, which is asking me if I would be interested to look at it. When the user taps on it, and it says there are insights related to business overview, which is essentially what I'm looking at this point in time. Are you looking to know the current state of your business? I would say yes, and it will show up the business overview. And here is some of these items that are essentially constructed using the same UI that we have seen in different screens. The total number of orders and total number of items sold. Whereas all these items that need my attention, things like low stock items or items about to expire, and the user could actually tap on more insights instead of navigating to the other screens, which the user would probably have anyways gone to, because I'm trying to get a overall understanding of my business. And this gives me like a quick summarization of all the things that I might be looking for, and in a much more categorized manner, which is essentially constructed using a lot of reusable portions of the server side driven JSON objects, JSON UI objects. And so, summarizing everything that we discussed so far, GenAI mobile platforms, they foster faster innovation and prevent duplication. The renderers that we discussed let you configure the format in which the LLM should respond. Personalized insights, they learn and adapt the user feedback and engagement and helps you improve insights over time. Actions framework, it proactively generates contextual actions from multimodality sensory inputs, reducing the number of manual steps needed. Adaptive content management builds AI-driven summarization, reusing UI elements in a derived context when there is no explicit prompt from the user. So that concludes my presentation, and I would be happy to answer any questions if anybody might have.
Hi, thanks for the nice presentation, and I think it's something to look forward to in terms of framework. This would be something that would be used as a general thing across. How can you define some guardrails? Like, for example, you want only some specific content that the LLM can give you, and it depends on your business or your context. So how do you instead of me just asking a random question and then it gives me some unrelated answers, right? So and preventing hallucinations and these kind of things. So
No,
if, for
absolutely.
example, if I'm looking at the inside, maybe there might be an issue where it might tell me something wrong. So there is that issue from LLMs as well. So how do we guard against these kind of things? So yeah, that's all I just
Yeah,
wanted to know.
absolutely. I think that's a great question. So, I mean, my experience with LLMs have been, it is more, the iterativeness that kind of gets you to your ideal state. And you should have a strong fallback strategy. It could be quite possible that, depending upon the kind of GPT model that you select, it could be quite possible that you may not get the response, in a format that you exactly anticipate. But more often than not, I think things like simple renderers like Markdown and stuff, they do an excellent job in highlighting the key information. So in case you have like a server-side driven DSL that lets you parse the or generate insights, having a stronger fallback strategy as well as a fine tuning query prompts over the period of time is when you get to an ideal state.
So I have two questions. One is like, is it like on the iOS side, is it like native UI being rendered, or is it like something React or HTML? My second question is how you are handling the analytics part on it. Analytics means like which screen I have selected and all those things, how you are handling on those part on UI side or iOS side.
Yeah, so analytics, we have a simple framework for analytics. We have some explicit feedback loop mechanisms where you have things like thumbs up and thumbs down, where the user could provide an explicit feedback. And we also have a built-in analytics tool, which are you could say simple tools which lets you create a dashboard view of things, based on the keywords. For example, I showed you the personalized insights. Depending upon the selections that the user have made and the choices that the user have rejected, you get a sense, from your dashboards, the areas of focus that you want to render for or areas of focus that you want to pay attention for a particular user. So that's how we build the analytics. We have inbuilt tool set into it. Uh, but your first question, if I understood this right, eh, uh, is this about how we do this on iOS?
Yes, is it like native UI which is being rendered, or is it like something HTML or something like that is getting rendered?
No, it's native UI. All the examples that I showed you is native UI, but some of the examples that we saw are driven by server side DSL. Essentially, it's a domain specific language which is a JSON. It has nodes for you to represent the UI, but what is rendered on the screen is all native UI. The implementations for the DSL is written in iOS, the Swift UI views.
Got it. Thank you.
Does anyone else have any questions?
Hi, one very basic question, like where do we do all this coding? What ID or how do we start? Let's say I want to develop an app. When I want to develop an iOS app, I open Xcode and say new project or something similar for the Android case. In this case, how do we start? Which is the starting point?
So these are, I mean, these are simple JSON. If I'm assuming you're asking about the server side driven development. So you do most of your development natively as a front end developer, because you're going to be implementing those views anyways on, in Swift or Swift UI, whereas the schema itself is generated on the backend, and you could use any tool, be it Code or Atom, or you could use any tool for it.
Okay, thanks.
But if we have to divide this development into two paradigms, one would be your front end, where you need the UI elements to be implemented so that your server side driven UI works. But I would encourage you to check out the player library, which is an open source library. It comes handy with a bunch of implemented UI for you, so that you could make use of it. But you can always add more to it, and everything is done in Xcode and Swift.
Thank you.
So I had a question as well. In personalized embedded summaries, you did mention something about feedback loop. So when you're noting down everything, how the person is interacting along with in that mobile application. So I wanted to know, would it have an impact on the performance of the application as well, if since the person is just everything that he's been doing is kind of just noted and cached and stored in the stored somewhere for every interaction he does. So would it not lead to like performance issues like in future if you're trying to talk about scalability of the application?
Yeah, that's a great question. So the strategy that we are applying here is more or less based on keywords. You're not fetching anything until so. I mean, we serve some insights which we think are useful for the user. But then any of the other insights where the user is, let's say interested in an area that you haven't served, that is more of a keyword, and that keyword essentially is tagged to some network call. For example, you have a keyword that says expenses. So and you only have like a few services on your screen or in any application, right? Those are not infinite in number. So the expenses keyword would actually trigger, some pre-configured query for the expenses data. So that way, the user would be served, summarization or insights for that particular keyword that they have selected. And you don't make a network call unless the user, actually goes on and selects. Whereas if the user ignores some insights which they do not like, so the next time when they save it and you open it, we completely wipe it out. We don't serve them the same thing, which means you're not making any network calls for that particular area of interest.
Hello. Yeah, so my question is around the action model itself. So currently, from the architecture that you have presented, the LLM processes the insights that you give, and then it actually produces the actions, which then gets performed in the mode. But I wanted to understand more around what kind of LLM are we talking about? Is it ChatGPT or something which have a functionality of function calling, or basically how a response of LLM is being translated over to some actions that can be performed over, on device, on mobile?
Yeah, great question again. So we use the GPT models. We use 3.5, 4, and I think we have limited access to Google's Gemini, and we have some internal financial GPT models as well, which are trained on our data. And the logic here is essentially telling the LLMs that hey, from this raw text, use the properties that I'm providing you, and do a match and send it back to me, right? Just like your core ML, even in your on-device ML, like Apple already does it today. But having it on the on-device versus having it on the server, because sometimes we might want to have consistent experiences across different applications, and your on device might not be as scalable, and training on device model is not very easy. Because they could be heavy and they could be very limited to act. The scope of it could be pretty limited, so we train them on the backend. Coming back to your question again, so just like how the core ML does the mapping on device with the properties that you have specified from by extracting the key data from the raw text, the LLMs does the same. But the only part here is we are providing them a bunch of options, because every action could be different, and every data model for that action could be different. So from a raw text, we are saying, hey, if you see a match, first of all, identify whether there is a match for the action itself. Like you see something that says Wasim and let's say a number, it could be quite possible that it's a contact card and it's not an email, right? So the contact card is the match, that's the action match, and then the next level of it is the first name as Wasim, and the phone number as the number. So that's what we're trying to get to. And again, LLMs are not quite predictable. So it takes some iterations to actually get it right, and that's why I always talk about a fallback strategy in case you don't.
Got it.
I hope that
So,
answers
is
the
it like it's a system prompt or something which you guys have prepared that in a certain format only you are expecting the response?
Yeah, yeah. So it is it is a system prompt. It's a simple prompt query, except for the fact that we are actually supplying a schema for it to use it.
Got it. Thanks.
Anyone else? Any questions? If that is all, let's hear a round of applause for Wasim. Thank you, Wasim, for the insightful session, and your passion for mobile dev and AI-infused mobile dev is commendable. Thank you for sharing your experiences and insights with us.
Yeah, thank you everyone for listening in.
Thank you, Wasim. Bye-bye. Next, joining here today, we have Swapnil Do, who will be speaking about ML in iOS. Swapnil currently is an iOS engineer at Loyalty Juggernaut, where he leads the iOS dev team and develops cutting edge applications for top loyalty customers worldwide. Swapnil has won the Apple's prestigious WWDC scholarship 3 consecutive times in 2019, 20, and 21. Outside of work, Swapnil also owns an independent app business with over 9 applications currently available on the App Store. Let's hear a round of applause for Swapnil.
Hi everyone, can you all hear me? Great. Thank you for coming to my talk. I'm going to be talking about machine learning in iOS today. More specifically, let me just yeah. Let me set the agenda for today. Okay. So we'll loosely talk about these 4 items. First, we'll talk about where Apple already uses machine learning in iOS. Some of the features that you've already used, such as subject lifting from photos, transformer models to do next word prediction, all of that we'll look at. We'll also take a look at some of the public vision APIs that's available for you to use the same features in your app. We'll then continue with how you can create your own custom ML models in CreateML. In that, we'll also talk about my WW21 submission, where I used ML to do handpost classification. We'll talk about why CreateML models are so small and so efficient by a method called transfer learning. Then we'll look at 2 specific use cases. One is called tabular regression. With tabular regression, we'll also look at one of the algorithms that tabular regression uses for training. And the last one is text classification. We'll take a look at how you can create a text classification model, integrate that into a Swift UI app, and then play around with it. All right, so let's get started. So Apple extensively uses machine learning in a lot of iOS features nowadays. More to come, obviously, I'm hoping this year at DubDub. But for example, the first one is subject-object background detection. So you can see here's the Merlion from iOS Conf SG this year. It shows that when you pull up the bottom sheet, you can see it says look up landmark. Yeah, so that's one of the top landmarks. So it's able to recognize landmark, and when you tap on it, it's able to give you more context about that landmark. So this inference happens on device, but of course, when it's trying to access more data, then it goes to the internet. The next one is the transformer models for doing predictions of next word. This came up in iOS 17 this year, so at DubDub 2023. They had a transformer model where it can do next word predictions. So, and this is contextual, so it learns from the things that you're trying to type, and then it tries to give you a next word prediction as well. You can access a lot of these APIs. Apple exposes a bunch of these through the Vision and Vision Kit. Now, the difference between Vision and Vision Kit is that Vision Kit is a much higher level framework. It comes with UI such as the VN document scanner view controller, and a bunch of other UI related items. But if you want to access the underlying APIs to build your own UI on top, you can use Vision. So you have stuff like image analyzer, document bound recognition, all of that is exposed via Vision. But it also uses a custom trained model underneath. Apple doesn't expose that obviously, but you can still use the particular use case for it using Vision and Vision Kit. There's also AR and AR Kit, but then it's pretty similar. Like in the way that it works, there's an underlying model. They expose some APIs you can build on top of it. Okay, that was about models that existed already. Now, how do you create your own models for your use case? And that's the interesting part. The thing is, Apple abstracts away a bunch of the complexities behind creating machine, because a lot of us are just iOS engineers or front-end engineers. We're not mathematicians or people who can build out custom models. But so Apple does all that abstraction out and gives you a very nice UI for you to do it. So the training workflow is pretty similar. Of course, you start with a bunch of training data. You use an app called CreateML. Then you validate that data, and then you test that data. So validation gives you an evaluation matrix on how the model performed. Then you test the data on stuff it has not seen before, and at the end you integrate it with your iOS apps. Now, that brings us to the first part. We'll go about each of these steps in detail, but the first part is CreateML. Now, CreateML is an app provided by Apple. It comes bundled with Xcode. So if you have Xcode, you also have CreateML. You can go to developer tools and you can search for CreateML. We'll look at that at the demo as well. But what CreateML essentially does is it provides you a nice UI where you can where it also has a bunch of templates. Yeah, so you can train a model based on that template. So image classification, sound classification, a bunch of these templates are already predefined. You can use CreateML for that, pass your training data, and it would output a .ml model file. This is how the CreateML's UI looks like. You can see that there are a bunch of tabs at the top, which does specific items. The first one is your settings tab. This is where the configuration for your model happens. So here we can see that there is a training data, validation data, and test. Now the good thing about CreateML is that even if you don't have training data, if you don't have testing, of course you need to have training data. But if you don't have testing data, what it can do is it can perform a split on your existing training data, and it gives you a nice set for you to train as well. But also with CreateML this year, and I think it was last year, that there is a new preview tab at the top. Yeah, so there's a new preview tab at the top. I think I can point. Can I point? How does that work? All right, doesn't matter. There's a preview. It's fine. There's a preview tab at the top. You can see. You can live preview your models right inside of CreateML. Yeah. So this is template dependent. So if you have things like text classification, that UI gets adjusted for text classification. If you have handpost recognition, that does it. Okay. There's one more interesting thing in CreateML. This is a template for image classification. Yeah. So inside of parameters, you can see that there is a feature extractor. So this is the custom model that Apple has already trained on billions and billions of parameters. But below that is where augmentations come in. Now, augmentations are very important because you might have created your training data based on a specific environment, specific lighting condition. Augmentation adds a diversity to that data set. So there's a bunch of augmentation that comes pre-built, and like crop, flip, and contrast, adding grain. All of this is done in-built if you just select those checkboxes. So what CreateML then does is it takes your training data, adds these augmentations to create a more diverse data set, and then uses that to then train your model. Okay, so what is CoreML now? CoreML is the underlying framework behind everything. Now, CreateML outputs a .ml model file. CoreML uses that ML model file to do all of its computation. The good thing about CoreML is that it does this on device. So it's privacy focused, which Apple is known for, as well as it's very fast because it uses the on-device neural engine with the new A series and M series chips. So it's very fast. And the advantage is that because it's on device, you can also do contextual predictions based on how the user is interacting with your model. So a model can be generic, but that model can then act differently based on how a user interacts with it, and even how a user interacts with it at specific times of the day. Okay, so CoreML team also has a very interesting model on GitHub. It's an interesting tool on GitHub. It's called CoreML Tools. Now, CoreML Tools is used for converting existing Python-based models into CoreML models. So to get an extension of .ml model, you can use CoreML Tools. We'll talk about why this is important, why converting it into a native .ml model file is important. But just know that if you go to GitHub and search for CoreML tools, you will get the CoreML tools framework. You can use pip to install that, and you can convert existing TensorFlow or Keras libraries into .ml model. Okay. Now let's talk a little bit about my DubDub 2021 submission. So in DubDub 2021, I created a Swift playground. So for those of you who don't know, you need to create a Swift playground for your DubDub submissions, not not an app. So it's a experience that you need to give to the judge for 3 minutes. So it's so you need to walk them through a process, basically a story. So usually if you focus something on health or accessibility, where Apple prioritizes their efforts, it's more likely to gain attention from them. But of course, it's not always about winning. It's about presenting and creating something from your own. So what I had created was a human handpost classifier. Now, why is this interesting? It's for a couple of facts. First is, when I started out, there was no human handpost classification model that was already available. Now, what I had to end up doing was go to Kaggle. I'm pretty sure a lot of you know about Kaggle. It's a place where you can get data sets, you can get existing models that's trained. What in Kaggle, I used a human hand pose recognizer model, which is pretty famous one as well. So it has a lot of these alphabets and it's grouped, so 3,000 images per alphabet. I used that, but the problem with that was it's not very diverse. It's of somebody who has a lighter skin and it's on a lighter background. So there's not much contrast between the two, and the tools that we were using to train the models was not very good at that, but trying to distinguish between the background and foreground. So I didn't have much time. It's usually during finals week. So this was my third year finals. I had compiled that year, so I had to not, I can't put too much attention on this. So what I ended up doing was, I remember in 2020, Apple introduced the human hand pose classification in Vision. Vision, again, is the framework we had talked about. Again, Vision team is very nice. Again, if you couldn't tell, they're probably my favorite team at Apple. I had multiple sessions with them during DubDub as well, so they're very helpful. What I remember in Vision was there was a human hand pose classification feature that was introduced. So if you look at a human hand pose, or even if you look at a human skeleton, we're made up of a bunch of joints. These joints are then translated into computer coordinates. So every hand has a bunch of 5 points, and then the wrist has 1 point. I mean, 4 points, and including the wrist becomes 5. So every hand finger position is controlled by one of these points. So you can get the coordinates for one of these points. So there is the tip of the thumb. So we are just looking at the thumb in this case. So there's the tip of the thumb, which is marked with blue. Then there is the green one, which is the interphalangeal joint. It's abbreviated as IP. Then the yellow one is called the metacarpophalangeal joint, that is MP. And the last one is carpometacarpal joint, CMC. So all of these points, you can identify them in space. Now, one thing is that Vision coordinates are different than UIKit coordinates. UIKit's bounds start at the top left, so 0, 0 is at the top left, but Vision has a regular coordinate axis, so at the bottom. So you need to convert those points into either one of the normalized frameworks and then do it. So what I ended up doing, it was a bit tedious, but if you look at an example like this, you'd see when the fist is closed, there is no vertical velocity, or there's no vertical movement. All of these tip positions of the index finger, middle finger, and the little finger, all of them are on the same y-axis, just that their x coordinate keeps changing. And then you can see that the thumb is also nearby one of the ring finger points, and then there's like quite a bit of distance between the base of the wrist and one of the fingers at the top. So using these kind of relations, I was able to plot the points in space. It was very tedious, so I narrowed it down to 4 or 5 items that I'd like to talk about. I trained my model to recognize these kind of lines. So if this is the condition and the hand pose is like this, maybe it's probably a B. So you would have noticed in my previous slide that there was a confidence builder. So I was not immediately trying to say, yeah, this is a B. I was trying to build confidence over time, and then if it worked out, yeah, that's probably a B. But fast forward to 2021, the same year I submitted, Apple introduced human hand pose classification, CreateML, which would have saved a lot of time, but yeah, whatever. So human hand pose classification still works on image classification. So you pass it a bunch of data set labeled in folders. So you say that this folder is for A, this is for B, this is for Y, and then you pass these folders into CreateML at the top, and it's able to figure out that there are 10 classes. So a class is a group of objects, and there are 30,000 items in total. So it's 3,000 items per folder. So we give it the training data, and you can see at validation data, it's done an auto split from the training data. So the validation data is used by the model itself to do a prediction of how well it's performing. And at the bottom, we again have those augmentations. So horizontally flip, rotate, translate. These are again dependent on what model you're using. So it keeps changing. So if it's image classification, it's different. If it's handpost classification, it's different. So what this did is it now used that same technique that I had used previously to do points based analysis. It does that by itself now. And in the preview window, you have this nice FaceTime window here where you can show up your hand and it would plot those points on your hand. And then it would give you a prediction at the bottom. So it says B with 100%, which is fantastic, which is what it is. So where can you get training data from? You can get training data from a bunch of places. Kaggle is one, Hugging Face is another one. You can also get pre-trained models from these places. And that doesn't only have to be the data. You can get models already. And you can use Core ML to then translate this data into .ml model. But there are a couple of other interesting places to get data as well. The first one is using online tools like ChatGPT. We'll use that for the demo as well. But the other one is user generated data. Now, your user might not be generating explicitly some sort of a data, but the way the user interacts with your app is enough data for you to train a model on. So for example, the way they interact with your app, maybe during the morning or during the evening once they come back from office, that is a lot of data that you can use to then train your models. And because Core ML also supports on-device machine learning now, you can use that data to start fine-tuning your model. Now you would have, like once we do that, you would notice, but I would tell you here that one of the models here, like this tabular regression model, this has a size of 2 kilobytes only, which is pretty fascinating because the model, the data that I trained this on, the CSV file, that was 30 megabytes by itself. Now, why is that this model is 2 kilobytes and the data was so big? The interesting thing comes here because a lot of create ML models use something called transfer learning. Now, what is transfer learning? Transfer learning is where there is already an extensive model that is trained by Apple on billions of parameters over billions of lines of code. So it's all trained and it's done, the hard work's done by people at Cupertino. But what you end up doing is you try to fine tune it for your specific use case. So for example, if I give you for image classification, Apple has done a bunch of work trying to train all these models on how images look different from each other. So how the foreground differs from the subject, all of that is done. What you end up doing is when you're trying to maybe make a model that does cat versus dog, it tries to detect specific features of what a cat looks like versus what a dog looks like. So it's trying to maybe look at the position of the ears or the shape of the ears and the, the pointy nose and all that. And then it superimposes these parameters on the existing model that Apple had already created. So another analogy I can give you is I play the keyboard. I've been playing for a while, but so I've been playing for a while. I know how the notes sound like. I know what the chord progressions are. I know how to play a song on the keyboard. But my brother doesn't like the keyboard. He likes to play the guitar. So once he got the guitar, I of course don't know how the finger positions work. But once I learned that, I was able to use the knowledge that I had from playing the keyboard into playing the guitar because I knew what comes after. If you use the Indian classical, so it's sarigama. So I know what comes after sa, so I know exactly how it sounds like, and I know if it sounds a little bit off, I can say that this is a little bit out of tune. So the main learning happened when I was learning the keyboard, so the chord progressions, the note progressions. But then I used that learning to then start learning the guitar by just fine tuning a few parameters. As in, instead of pressing the key, I need to now press this this string, and then strum the chord. So that's how transfer learning is, and that is why these create ML models, they are very tiny. They only contain the parameters that is required for your fine tuning. It doesn't contain the model and doesn't even contain the images that you trained it on. So license wise, it's safe, but of course, if you have used somebody else's data set, it's always nice to attribute them and give them some copyright thing inside of your app somewhere. All right. So we'll talk about two specific use cases of what we have discussed right now. The first one is called tabular regression. Tabular regression is a specific use case wherein you have data which is in the form of CSV. So this is not image data. This is CSV inside of an Excel format. This is how tabular. So this is what tabular regression is. The way it works is you have, say, if you have 3 columns inside of your CSV file, it takes the input of the first 2 columns and then it tries to predict an algorithm that can do the best fit for the third one. So, like you have, like for example, if you have a real, like if you're a realtor and you have data set on a bunch of houses, so you can say that if it's a 2 BHK house, like a kitchen and it's like a hall, the hall's pretty big, you can say that maybe it costs around $40,000. But you can use that data to then start predicting houses that are of similar type in the similar area. That is where tabular regression comes in. Tabular regression's evaluation criteria is two of them. One is called mean absolute error, and the other one is a mean squared error. So the only difference between the two is mean squared error is the average error that you get. Root mean squared error is the average error that you get, and the absolute error is the most error that you're getting. So usually, if your absolute error is very off, it's better to train your model again and tune parameters. But your mean root squared error is the one that gives you your average error value. That maybe if it was a $40,000 house, maybe I predicted 41,000, and that is consistent across the entire data set. Okay. So this is an example of tabular regression. So this is a data set from flight movements at New York's JFK Airport last year on some day. And there's a bunch of data here, but the interesting one is at the one at the end. So there is something called a taxi out time. Taxi out time is when the aircraft is pushes back from its gate and starts taxiing out on its own power. So that is the data that's marked in the red column. You can't see it, but the idea is that we're trying to figure out how you can predict taxi out time from the data that you already have. So for example, in New York, I think there are 4 runways that work at the same time. So you have the runway conditions, you can have the wind conditions, you can have the humidity on that day. All of that can predict when the taxi out time is going to be. So how far delayed is the aircraft probably going to be. And this trend continues every year. So you have every year you're trying to predict this. The more data you're getting, the better your model gets at predicting. So with this, airlines are able to plan in advance that maybe because of this weather condition, there will be more backlog on the runway. And for that, we need to add some buffer time. So maybe the flight will be delayed already. Tabular regression works on this like there are a bunch of algorithms. Apple will choose the best one when you're using CreateML, but one of the algorithms, the simpler one, is called linear regression. Linear regression is cool because it's easier to understand. Each of these points are the data that's plotted in space. So for example, if the weather condition was, like if it was windy on that day and the runway was wet, maybe then the point is at the bottom. So all of these points are plotted, and then the model is trying to predict which is the best fit line that goes through most of the points. So you can see the model goes through here. So there will definitely be outliers, we'll call them anomalies, and they'll be at the top and bottom, but you're trying to not skew the data towards them. You're trying to make a best fit line that passes through most points. Once you have this data, CreateML is then able to predict, maybe if certain conditions match, if it's near the line, maybe it's going to be somewhere around that the delay time. So that is what linear regression does. There's also boosted forest and random boosted forest, but I don't know about them. So we'll talk about linear regression. Okay, so this is how the UI looks like for when you're trying to train a tabular regression model. Here you can see that there's a target and then features. So what features does is this is where you're extracting the features out from the model. So this is what you're trying to use to predict the third column. So you're saying here the day of month, the day of week, the tail number, the type of aircraft. All of these are the features that I wanted to try to figure out, try to analyze them. But the target is taxi out. That is what I wanted to figure out from all these features. I pass the training data. Again, it's in a CSV format. I pass 28,820 items, and it does validation on it, and it gives me a model out of it. Now, the last one that we're going to talk about, which is where we'll also do a demo, is called text classification. Now, text classification is rather simple compared to tabular regression. What text classification does is it's able to categorize labels into particular groups. So you can have spam folders, spam detection using this. But more specifically, what I use it for in one of my apps is if the user has typed Zomato 100 times and they've selected the category as dining. So it's probably safe to assume that Zomato is a dining category item. But this Zomato thing does not work everywhere around the world, right? There's DoorDash in the US. Um, I don't know. There's something in the UAE as well. I forgot what it's called. But there, like all of these can be used to train. So what I mentioned earlier was user-generated data is very helpful because if the user is selecting Zomato and they select the category as dining 200 times, you probably know that Zomato every time they type Zomato as the type of expense that they've recorded, it's probably a dining. So it's nice to suggest to the user that maybe this is a dining thing. So you can even categorize it earlier that way. There's a bunch of evaluation matrices as well, but what we are going to do is we are going to see how you can generate this kind of data. You can of course generate it using a bunch of models that's available online already on Kaggle and Hugging Face, but What we are going to do is we are going to use ChatGPT. So you can use any online LLM service now. You can use Claude, you can use Meta's Llama, you can use all of that. But the idea is this. You need to create an array of dictionary objects, an array of JSON, with the key being text and the value being label. So the text is the sentence and the label is the group that you want to put it in. And then what createml will do is you pass this JSON into createml, and it's going to then split the data, and then it's going to train data. It's going to train the model on that data. It'll also give you a very helpful preview window where you can then use the preview that comes out from createml, and then you can fine tune your model. So you can increase the number of iterations, you can increase like documentation. So you can do a bunch of things. But then once you get a best fit model, we'll extract that model out into a Swift UI app, and then we'll see how you can get the user input, click a button, and then make a prediction. Of course, we're going to train it on like probably 30-40 items, so it's not going to be accurate at all. It's probably foolish to even do this demo, but it's nice to see how it works, and maybe luck will be on our side and it'll work. But anyway, let's move towards the demo now. Okay, so I'll have to do the demo sitting because we have forgot to do a few things. But anyway, you're all able to see my screen, right? Okay, so I have a chat GPT prompt that was made already. So you can take a look at the prompt. So it says, give me 100 JSON objects with key as text and value as label. Each of the keys should be a sentence and the label should be a category of that sentence. And it should be within any 5 categories. And I've also provided it the schema, so the key and the label. And you can see that ChatGPT has created an array of dictionary objects, so an array of JSON objects with text and label. Now, what we are going to do is we are going to try to bring this in as a JSON using VS Code. So we'll open up code. And we'll copy this, paste this, and we'll save this. All right. Okay, so I've saved the file. Now let me take you around CreateML. So I'm opening up the CreateML app. You can go through it using Spotlight, or you can go through it via developer tools in Xcode. So once you have Xcode enabled, you can go here to Xcode and then click on open developer tools, and then you can go to CreateML. But once we have CreateML open, we'll create a new document. Now we have a bunch of these templates here already. So image classification, multi-label image classification, word tagging, but we'll take a look at text classification today. So we'll give it a model name and then we'll create here. Okay. So we have a training data, validation data, and testing data. What I'll do is I'll bring in the JSON that I had just created and I'll drag and drop it inside of training data. So it says that there are 10 classes with 79 items. And then I can give it a number of iterations as well, or it can just use the default 10, but it will stop whenever it finds the best fit. So that doesn't really matter if you have a small data set. And I can now click on train. So training's completed on 10 iterations. It's rather quick because again, it's doing feature extraction. So in evaluation, I can pass it another JSON for it to evaluate the data. If I, of course, pass the original JSON, it'll get 100% accuracy. It's still not 100%, but still. But in preview, we have a nice text box here wherein as we type and when we stop typing, it's able to give us a confidence prediction. So if we take a look at the JSON, we have art and education and health. Maybe we can type something like, yeah, thank you, thank you. Right. So you can say, I don't want to go to the doctor. Or maybe let's try the sun is very bright. So it gives me weather with 21% confidence. So we can now of course, as and when you have better data, as and when you have a lot of data, this will improve. But now once we have this, we can take the output of the model. You can again see that it's only 7 kilobytes and it has a bunch of class labels here. Now we are going to just extract this. So we'll say get and then we'll store it here. Now let's go back into Xcode. Now the interesting part is because this is all a native interface, we can go into documents and we can bring in the model here. So once we drag and drop the model, you can see that Xcode has a very nice interface for dealing with the model. So you have all the class labels. You can do preview right in Xcode, and you can have a model like a model class is already generated for you. The model class is used by the language for you to interact with the model directly in Swift without having to do any bridging. So let me now just type some UI code quickly. So I have the UI code ready. I mean, it's not a nice UI, but the functionality is what we'll write now. So for the functionality, let me just write it once and I'll explain it quickly. Okay, so we have written some functionality code here. First, we created a ML model configuration, but before that, we imported the core ML framework. We created a configuration, and then we initialized the model with that configuration. You can also use the default initializer, but that's deprecated. So if I use the default initializer, Xcode will say that init without anything is deprecated. So we'll use configuration, and you can see that this is all native Swift. You don't have to do any interoperability with anything else. And then you can simply call model.prediction. You can pass the text, which is here. And then on the button, we are calling the predict function. And then this will set the prediction to this optional variable here. So if there is some optional variable, we will then show that on the UI. So let me just say here. You can see that at the bottom, it says the prediction is weather. You can try out with different items, but it works. So I don't want to break it. Okay, yeah, I think that's it I had to do in this. But yeah, that was about it. But again, there are a bunch of things. These are just like scratching the surface essentially. There's a bunch of things that you can work with. Image classification, sound classification. Sound classification is also very interesting because it can work with a stream of data. So you can have a timestamp based. So like the first 10 seconds was guitar, the next 10 seconds was the keyboard. So you can have all that data. All of that works natively with Swift and the iOS ecosystem in general. And it works on device. It works on multiple Apple platforms. So Apple TV, the Apple Watch, bunch of things. So get your hands dirty. Get work with your users' data essentially to give them more personalized insights into their data. Of course, it's very on device. It's privacy focused and it's contextual. So depending on the time of day, depending on the user behavior, you're able to suggest things to the user or maybe make their life easier in your app. That's it. Thank you so much. Let me just. Yeah, time for some question and answers. Yes, please.
I guess something. I'm sorry, I'm not audible. Okay, I can hear you, but I think you might have the mic. Okay, so my question was there was also a field for choosing the algorithm when you were training. You use something of related to entropy. So my question is like there are many tons of algorithms out there like ResNet 50 and such when it comes to image classification. How do you decide on like choosing which algorithm to go with? Like, is it just through trial and error, and what exactly?
Right. So it's a good question because there's a lot of algorithms that's already available inside of CreateML as well as available on Apple's developer website. But using CreateML, the idea of using CreateML is for anybody who has not worked with ML to add some ML into their app. So they try to abstract out a bunch of the, choosing what algorithm best fits. But as you mentioned, trial and error is really what works well for your data set. If you already know what can work well, you can choose a specific one There are only a few options that's available here, but you can of course train a model with Keras and then bring it to Core ML. That also works pretty well. But mostly it will choose the best fit algorithm for your data. So it does an analysis on your data when you input it, and it will figure out that maybe random boosted forest is the correct algorithm, or maybe the one that will give it the proper result. And or the best part is that once you get the evaluation metrics back, you can then feed it back, and then you can use the data that was already trained on. You can train it again, but this time with a different algorithm. You can then compare which works better for your data. And then of course, as you increase the data, or as you make the data more precise, it works better, but mostly through trial and error. But feedback loop also works. So try with the first algorithm, doesn't work well for your data, come back and then use that initial knowledge and then try a different algorithm. Yep, essentially that. Yes.
So also there's also feedback that you mentioned out. So nowadays there's like feedback loop that exists in the neural networks. So how exactly to achieve such thing out over here? Maybe through like person's interaction, as you mentioned that if suppose he types in Zomato or something, so I already have a fixed data set. What if I want to increase the data set based on what the person is looking at? So maybe the person fills in the key and the value pair himself, and I want to add it into my data set. But now that it has already been trained, it won't like acknowledge that outright.
Right. So that's a good use case for Apple's on-device machine learning. On-device machine learning works kind of like transfer learning, wherein you already have your create-ML data, create-ML model that was already created. But then what you end up doing is for a specific use case that the user is doing. So all users will generate different kinds of data, financial data if you're working on a finance app, food delivery app, all of these, and music apps. So maybe at different times of day, they want to listen to different types of music. All of that data, once you generate it, you can then feed it back inside the existing model. So I have not touched upon on-device training here, but if you look up on-device core ML training, you can figure out like how the user data can be then fed back inside the model that you had created, and this can be done at compile at runtime itself. So it does not have to be data that you already have. But if you're collecting analytics, it's nice to have that data, an anonymous data come in, and then use that data to maybe better train your model and benefit all other users. But yeah, like on-device machine learning, you can look that up. That will solve the specific use case. Yeah.
Yeah, so I actually had one question. So if I remember correctly, you said that, the model is already there. You would just, have the transfer learning data with it. So my question here is, and we talked about privacy, right? So my first question is, does the model sit on the device itself, or is it actually on at a network? Because because for having a good accuracy, you would need a lot of a big model, which could be queried for the query and get the right response.
Right. So all devices, all models are on device. So it's part of the operating system that comes. So every new model has to have another OTA update of the operating system itself. Usually every major release of iOS comes with a brand new model. Last year, they brought in BERT embedding for text classification. Before that, they had a bunch of ResNet ones for image classification. But it's a iterative process that they do, but all the models sit on device. So the transfer learning happens on CreateML, but if you're doing on-device machine learning, like I mentioned, that does transfer learning again on device. So all of this happens on device. There's no data that goes out. There's no data that comes in, unless explicitly if you want some data that come from outside. But everything that happens for Apple's devices, it's part of the operating system itself. So CreateML models will not work outside of iOS's or like Apple's ecosystem context, because it only contains the parameters that it's used to fine tune the model. So the CreateML model metadata already includes which model it's supposed to transfer learn on. So it knows like maybe this is the BERT model. On BERT model, I need to add these parameters and fine tune. Then I'll get the specific model that the user is looking for. So that's one disadvantage. Obviously, it's not. It's very platform specific. It's locked into Apple's ecosystem. I don't want to use another word, but it's locked into Apple's ecosystem, and because of which it's good in a way because the models are tiny, it can run on-device inference, but then you don't have the underlying model that it's supposed to run on, so you can't take that and run it somewhere else as well. But yeah, for your question, everything, whatever happens with CoreML and CreateML on device, unless explicitly you're getting data from outside and then training it on device. But yeah.
But then, I mean, from what I've read somewhere is, when you kind of compact the model, that is, you optimize it to a certain extent, the accuracy usually gets a hit. So since it is an on-device model, I mean, what is the kind of accuracies that you have seen with even with maybe some generic stuff, but also with some complex stuff that you've tried on?
So I've been using these text classification models recently in a couple of my apps that I make. So Windfall is one of the app with expense tracker app. So it's been working fine, but then I am training it on data that the user is generating. So it's very user specific. So if a user is interacting with the device in a particular way, usually they have those characteristics of always interacting in that particular way. So in that, for that user context, it's very helpful for the user, but maybe that same data will not work outside. Maybe for that user it's fine tuned, but then when it goes outside of that context, it's not very accurate. So from my example, like from my experience, image classification has been decent, text classification has been very nice in iOS 17, but there is still definitely some work that we need to do if you're trying to get a very specifically trained and high precise model. But for little bit device on device inference, it works pretty well. So usually createm is like a good starting point. It's not supposed to be the end game, but you are able to use existing models that's already very very well accuracy on the internet. You can use that to convert it into core ml, and you can use that if the accuracy and is these things are important. Most companies that I've worked with, they have their custom model that's trained on bunch of data. They host it on somewhere and then they download it at when the app is installed. But for indie developers, small startups that are trying to integrate some intelligence into their app, this works very well. But yeah, it's not very accurate from what I've done, but I don't expect it to be that accurate with the amount of data I'm providing. So, but yeah, that's like fantastic point, of course.
Thanks.
Thank you.
Hi, I'm
hi.
Yashasuni, and this was a wonderful session. The question I have is when you take a model from Keras or TensorFlow, and then you bring it into Core ML and using Create ML, what about the accuracy? Will it reduce? Will it take a hit? Or will it be as good as in TensorFlow and Keras?
Okay, that's a great point. That's a great question because what essentially Core ML is doing, it's trying to convert the input matrices into something that we can provide from iOS. So iOS has 2D matrices. iOS has things where, for example, and when we're doing hand post classification, it's able to just extract the data that iOS can provide it. So when we are running it on like maybe Google Colab, we have a specific way we provide the data, and then TensorFlow, like the model looks at it and then makes the prediction. But what Core ML tools essentially does is it tries to convert the input data into whatever the model requires. So when we are accessing it from the iOS app, it looks very native to us. So we are trying to just get the matrix build and then we submit it to the model. The model underlying does the same exact thing as it was doing with on Google Colab. It's just that the data input and output is formatted in such a way that it works well with iOS. But if whatever the model accuracy was earlier when working with like Google Colab, you'll find the same accuracy here, provided that you can provide it the exact same data. So if you can provide it the exact same types of images, and Core ML tools has done a good job in converting the input from iOS into what matrix input that it wants. If it can do that well, then the accuracy is exactly the same because the underlying model is the same. It's just that the input output keeps changing. But again, the problem with that is when you're converting existing models, the size of those models are pretty big. They do not use transfer learning like CreateML. So size of those models are pretty big, and it's easier to host them somewhere else and then bring them in. But accuracy wise, you'll get pretty much the same accuracy because I had trained that for, I tried that for my 2021 hand post submission. I used one of the existing hand post classification ones. It worked well, but I was having troubles converting the dimensions, the coordinate system between vision and UI kit and then what the thing was looking for. So that didn't work out. I didn't have enough time, but I'm pretty sure that if you try to get it into the input it's waiting for, then in my experience at least, it has been pretty similar.
So, according to you, if we have a very large model that we have trained using Keras and TensorFlow, it will not diminish its size when it comes back to.
Yes.
Okay.
That's one point. Yeah.
And one last question that I have is given the small size that you said, it's how well is it for Apple Watches because it's a small form factor? And if we have small models, how well will it work there?
So it works well. Again, it's running on the same neural engine that's on the A series chip and M series chip. So they have the same version of the neural engine that gets for one particular generation. They have like, so if an S3 chip comes out for the watch, an M3 chip comes out for the Mac, and an A3 A 16. What's going on right now? I think 16. So whatever comes out, so all of them have the same neural engine. So underlying tasks are done well, but of course it's much underpowered than the iPhone. So tasks will work because it's optimized in such a way that it's supposed to work on Apple TV, Apple Watch, even the smaller form factors. But usually the amount of training that we're doing on device is for very small, minute tasks. Like we're trying to predict health data, like when the user might go out for a run or something like that. So all of that little bits of data is processed on this. But from what I've seen, I've also worked on a fitness app for the Apple Watch. We have used models that we have again trained for the iPhone back into the Apple Watch. It's been well, but again, it's not something like, it's not a big model that we have trained on. But from the native interface has worked well for us, even with that small model, because underlying it has the existing model already. It's just trying to fine tune it for a specific use case.
Thank you.
Thank you.
Is there a inbuilt observability around the on-device training? Let's say I deploy my model and then it starts to train on user-specific data. Somewhere it starts to go wrong. So what kind of observability do we get on top to like be notified if at all it starts wrong?
Yeah, that's a good question. The two ways that I use is I collect analytics on the type of so users are grouped in my analytics software. So I know, even though it's an anonymous software, I know that this user has this kind of behavior with the app. And I'm able to then ask the user, this prediction was made by machine learning on device. Of course, it's not a technical term, but I'm just trying to tell them that this was not made on, like, it was not hard coded. This is something that came because you were interacting with it. Was it helpful or was it not helpful? This feedback loop is very important. If it's helpful and you record that data on an analytics software, then not only can you use that to fine tune your users model, you can use that to fine tune a bigger model for everybody to use data on. But yeah, this feedback loop is something you need to get it, but the model will keep telling you how much of an accuracy it's getting compared to the training data it's gotten. So that feedback you can get directly from code itself.
And how do you optimize like further updates to your model? So let's say in your next app update, you do some things that increases the accuracy, and now there's one already deployed on the user side. How do you directly replace it, or?
Yeah, so I for my indie apps, they're not that big still, hopefully soon. But once they become big, what I would suggest is getting it on Firebase. Like if you're using Firebase, then something like real-time storage or Firebase remote config, not remote config, but that's only for data. But if you have, you can store these kind of data, and then you can download the model at runtime. So when the user is seeing the onboarding, you can download a newer version of that model. It's always important to version your models and to add some metadata as to what has improved from the previous model. But then like during onboarding, you can pull this data because it's a very small model, and you can also assign, this model will work well for iOS 17.4 plus user, maybe because there is an underlying better model that works. So all of that, like right now, it's all every app version. But what I would suggest if you're working on a bigger app is to store it in a remote server and then download it during like onboarding. Especially because the models are very tiny, it won't take too much to download, and you can always have like the latest models on cloud, so you don't have to have the users update your app. But yeah.
Is there a way to like get the parameters or weights of the model after after it has been trained with user data as well?
I am not sure. I don't think that's possible with the core ML models as such, because Apple abstracts away a bunch of these things. It's just the UI nice, the front end part of it that's exposed to us. But I don't think it's possible with what we have worked with today. Maybe with some existing models that are trained in converted into ML model, maybe those, yeah, but not with what we have right now.
Got it. Thanks.
Thank you.
So I have a question. So for this hand post submission that you did you actually use the sign language or?
Yeah, American Sign Language.
Okay, thanks.
Yeah. So basically the points in space and then the relationship between those points. So the tip is all on the same y-axis, and the base of the thumb is near the wrist point. So all of that relationship model. So I couldn't do too many of it. I did 5 of them, but still won me the thing. So it's nice.
Okay, if you all have more questions, I'm afraid you all will have to take it up offline in the break because we're taking a quick break. Thank you, Swapnil. Now that's what passion sounds like. Let's hear a round of applause for him. Here, where? The talent. Okay. Okay, okay. So we have some of our talent acquisition folks. Yuvraj, if y'all can raise your hands, yeah. Yuvraj, Risi, Zishan, and Kirti, and also Charulata. They're not here. Okay. Okay, Zishan and Yuvraj are here. So please reach out to them and network with them in this break we're having if you are looking for any opportunities in mobile dev at Intuit. It's time for a short breather. Go grab a cup of coffee, stretch your legs, and don't forget to network. We'll resume in 10 minutes. We'll meet at 2:25. Actually, a little less than 10 minutes. Let's dive back in with Pawan Itagi. Pawan, hi. Okay. So, who will be navigating us through the process of enhancing Xcode with AI, building smarter editor extensions. With over 12 years of experience in software engineering and management, Pawan is a senior engineering manager and a mobile applications architect at Code and Theory, a global creative agency that designs products, content, and campaigning across platforms. Pawan leads a team of talented engineers who deliver cutting edge solutions for clients across various domains such as healthcare, fintech, e reader technology. E-reader technology, e-commerce, and hardware integration. So let's hear a round of applause as he comes on stage. It's already on stage.
Thank you, everyone. I hope everyone is still awake. Okay, I just wanted to, before I begin, I just wanted to ask everyone, how many of you have already used GitHub Copilot? Oh, awesome. I think all of you know, right? It's an amazing tool which can enhance your productivity. And so do you know how have you used? Because earlier I looked at, using it on the IDE, but then I found out it's only available on VS Code. Is there any other IDEs you have used? Okay, okay. Anyone got any solution for Xcode? Mm-hmm. Okay, okay. Yeah. So this again, like, sorry. Yeah, I think you want to add anything? Okay, 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 cool. Yeah, I think this is the same thing when I looked at the VS Code and then I figured out, okay, why or what iOS developers have done wrong. We should have something, right? And then I started looking at the different options which we need to look at. And yeah, then I landed on one of these. I worked majorly on end user applications in iOS, but this was new to me, right? So this is in the area of Mac application and building extension editors, right? So yeah, so let's begin. So yeah, about us, I work for a company called Code and Theory, as introduced, and what we do, right? So currently we are a design agency. That means like we have a balance between engineering and design. That means we don't only just work on the tech part, we also work on the user experience and how do we build a better experience for clients as a digital partners. And not only specific to mobile, we work on across all the platforms. And yeah, when it comes to, I think the last meetup we were discussing about, few team members had a question regarding like where the mobile is going, what they want to learn as they take the next step, right? And then this is where this also triggered a bit of curiosity in me and my team members, and we started looking at like what is the trend looking at, right? And if you look at the trend, which is we picked it up some of the known sites, and it says that global market it is about to hit 700 billion this year, and also we did some specific on the US market itself. And then again, what is the key is that I think what Swapnil and Wasim has brought it up, right? Personalization, and personalization through the user own data, as well as somewhere you get the insights from the market and then you do personalization, right? And then after that, if you see every user is going towards mobile, and that means like they want to have the quick access to the data, even if it is a very big or old organizations like healthcare, they are still going towards making it easier for the user. So that means the user, we are going to see a lot more usage of mobile going to forward. And then again, user engagement is through apps itself. The more personalized it will be, and the more they will use it for themselves, right? Okay, so now we know that mobile is not going to go down, and again there will be a debate around like, do we want to continue in native and Flutter hybrid? So there is a kind of discussion which we'll continue to have, but again it all depends on the what we are trying to deliver, right? So along with this, what I wanted to bring in is what is the opportunities ahead, right? And one of the thing which came into highlight is Gen AI, especially from last year to this year, when the Chat GPT which came in into the market, which had a very easy user experience, even though the GPTs existed long ago. But this is where the trend is going towards, right? If you see the market, it is going to go hit trillion by 2030 itself. And this is where we can align the Gen AI and mobile into the picture. And how do we do it for specifically for user experience? I think Swapnil and Wasim gave a great talk about it. I don't want to go in there, and they have hit a very deep dive. But I'll just go towards what we want to do from a developer perspective, right? So before we go there, we want to look at some of the challenges, what we want to do, right? And what we'll see and how will we go towards solving them. First one, I think all of you know the data privacy and security, not only just from a user experience, as in like how do you use the user data, but this is also comes into picture when you are writing a code and you don't want to expose any sensitive data which you are writing, right? And especially what we work on is we work closely with the client. So that means we work with clients' own code, and there should be a data privacy involved. So how do we bring that into picture? Because there will be a lot of compliances we need to agree with, right? And then intellectual property concerns. This is also one of the part where the code you have written, you have to make sure that it is not taken out from others' code base. So that is also one key part. And then the quality and control. The code which is getting generated also has to be high quality. That means it has to follow your own standards. You'll have to train on own standards and control it. And then also at the same time, you don't have to build something new. You have to build something which can integrate with your current system itself. So that will help us reduce the way user acquisition. User acquisition now I'm considering as a developers, right? We want to make it easier for them to get onto it. Keep the learning curve very low. So this is how we should look at from a high level, right? And then, yeah, so when it comes to, as I mentioned again, there are multiple ways to improve the user experience. So there are a lot of phases where we can integrate the Gen AI, right? From a building perspective to code delivery, as well as even the writing, and then we can put it in the CI/CD. So there are a lot of ways we can do it. What I'm going to touch upon is today is only for the extension editors, and this is a very basic on how we can do it. But there are a lot of ways to improve this and make it better to improve the code quality. Okay. Okay. So when it comes to the this is how we will go into deep dive. First, we'll see how the architecture looks like, and then I'll show how do we set up a sample application, and then how do we customize it, and then how do we integrate with the OpenAI for now, even though this is not the ideal solution at the moment. And then what are the limitations to do it, and how do we distribute it? I'll show one of the distribution solution, but there are other ways we can distribute it. Okay. Cool. So when it comes to extension editors, right, they don't exist in standalone. So they'll have to be built as a part of the containing app itself. This is similar to other file extensions, and then the other extension which were introduced earlier in 2000 iOS 8 when it was came around. So similar to that, this is a similar extension what we need to build, but there should be a container app. Container app doesn't have to have any functionality here, but it just have to be there so that it can hold this extension. And extension will only work on the clicking of the trigger, right? And if you see here, I'm showing that there are a lot of files. you can customize it for a particular type of file, your actions and what it needs to be done, and even it can show and don't show it also, right? So that way, and also extension works on the active source file currently. It doesn't work on something, you know, which is not in the focus at the moment. So that way, it is solving some of the problems, saying that it is not going and reading your code in the background. So it has to do only show what you tell it to do, right? Yeah, so this is whole existing in the Xcode itself. Okay, now I will show, I'll show how to set up the sample application first, and then we'll go into customization. Okay, so if you're all of you are seeing, this is, I created a sample application for now. I'll just close other one. Okay, so this is the application, and how we add another, how we add the extension is through adding a new, and then you can say target. And then here we say, okay. So when it says activate, I will say it as activate. So here, if you see, you can see a different target altogether. And if you go inside, you'll see that there are two files which are created, an info file, and then also there is a this one. So let's see what is this first file. So basically, we're not going to do any changes in this file. It's a very basic, but we can do some customization here as needed. But majorly, what we are going to deal with is on this file, right? And it says editor command. So that means every time you hit a command, you select a command, there will be an invocation which comes. As I showed in the architecture diagram, every time it triggers, this will be called. Okay. So now I usually what we need to do is every time we run on Xcode, we need to see an extension here. For example, I created two extensions. One is it is in the public when I created this one. So let's say I create something, I need to know this is the command hit, right? So how do I show this extension in this list, right? So what I will do is I'll go to the general section. For now, since it's a development stage, I'll just create it as a embed without signing. Okay, and if you go to the target, okay, so here basically you can see everything. Here, when I go here in extension attributes, and then this is a principal class, and then here you see item 0. Item 0 means in this extension I'm supporting one action itself, but you can add more items and make it extendable. And then here you can see that there are three keys and values. One is the identifier, and one is the command name, and another one is command class name. Okay. So what I will do is command name, I can keep it as is. Okay. And okay, so just give me a second. I need to change one value here that will enable us to show it in the screen. Okay, I just need to say in the identifier here. Okay, cool. So let's run this. While running, it has to select as a Mac application. So when you run this, it will ask for different application you need to select. Either you can customize it and fix it as Xcode from your scheme management system. So now I will select the Xcode now, and so what it will do is, if you see, it should launch another Xcode, right? If you're seeing here, yeah. So if you see here, this is the under the development testing mode. This is what the real Xcode is. Okay. So I'll select one of the application here. Okay, now let's see if it is visible, right? Yeah, so now if you see in the extension, it shows that there is a command which is available as source code command. Now it will not do anything because the command file here itself doesn't do anything. So let's test it out. Print. Okay, let's build it again. Okay, for now, just I'll click here and see if it is printing. Okay, so in the existing Xcode, which was the earlier parent Xcode, it is printing hello. That means whatever we're clicking, the trigger is getting added here. Okay, so this is the first sample application setup, and I can close it. Once I stop the running here, it will just exit the other Xcode by default. Okay, so this is how we can set up a basic extension. But what I will show next is what I have done and how do I integrate it with the AI itself, right? Let's close this one. Okay, so for example, let's run this code. I'll show how it looks and then I will go into details. Yeah, we currently are at the mercy of how the GPT-4 responds. But what I will do is I'll click and see if it is visible. So if you can see, currently it shows as improve my code. That is my current extension. And here I set up two things. For example, solid principles and write unit test cases. So what I'm telling is when I select some text and I ask it to adhere to some of my rules which I want to set up from a org wide, and then it will check it and then also responds. So let's see what will happen. Okay, so currently if you see here, this is generated by the GPT-4 itself, and it shows I want to convert this to adhere to my solid principles for now. This is a simple prompt. And then what also I will do is, let's click this. What I will say is editor, I'll say write test. Okay. Yes, it has given me a unit test code as well, right? So since I mentioned about the limitations, right, it only works on the active source file. So that means you not be able to create another file for now and then move the code there. But for now, this is what it is doing. Like currently, it check the selection and then creates and send it to the GPT-4 and gets the response back, and it also just puts the code here. This is the main thing here is that you will have more control over what and how do you want the response to be, right? So this is a sample application what I'm showing, but let's go in deeper, like how did I do it, right? So as I mentioned, the first code is that I changed my command code here. So every time I click, I get a trigger here. So what I will do is I'll set up my commands here as a setup function, and then when I get the detail, every time I can get an object which is getting converted from the invocation. So invocation will have all the data of your selection, the text, and when it is starting, where it is ending in the file itself. So that is where I'm converting like what is the identifier. Identifier means what is my command, right? And then I'm getting what is the selected text itself. And then what is the selection? Selection means it will give me lines and everything. And then the source is that, okay, what is the source? The invocation also has a buffer. I'm just getting the source, and this is required for me to take it for the next steps, where I am calling that, okay, get me result, command manager, get me result. And here it is just calling depending on the identifier, that means command. I'll just call the function. Currently I've set up a solid principles as one file, which is here. And then the unit test cases. This is a separate thing. So currently I have hard coded my prompt into the file itself. But as Swapnil was referring, right, we can do a remote configuration. Let's say Firebase or anything, where you can just post company-wide rules into one file, and every time it launches, we can just pull the file and then do it. And then it is calling, currently it's calling OpenAI Manager, which is another dependency I have added. But this OpenAI Manager can be replaced with any other services, right? Let's say, as Wasim was saying, that running your own LLM models, you can host it in one of your infrastructure. That way, you're not exposing any of the sensitive data, and then just call the function and then only learn on it, right? And from this one also, we can trigger it to learn as well, saying that, okay, this is what you want to learn, and then also get the data back, right? So yeah, so this is basic setup and running of this one. I know this is not a perfect code. It can be, refined more. But yeah, this is where I wanted to show, like, how do we set up a smart extension itself, right? I'll go to the next screen. As I mentioned, this is deals with current active source. This is one of the limitations we see, and only triggered by item clicking. And then other thing is that it has no UI for this instance. So what we need to do is has to go through the actions itself. Currently, I was not getting how do I show a loader, but it's not possible. But I think if you have used Copilot in other IDs, it has really nice options because of the way the IDE supports itself. So yeah, I think probably we'll get there in some time. Okay, how do I distribute this, right? So there are three ways of distributing. One is that source code compilation, and you can create a DMG file of your current code and then share it across. And also third is App Store. I think if you go to the App Store, Mac App Store, you will find, you can search for Xcode extension, and you will find a bunch of options there. And I'll show how do we, how do I share it through source code compilation, right? And it's pretty simple. Let's say I will, do a product and then archive. Okay, now I'm able to see my archive. So what I will do is go to show finder and then show package content. So if you see here in products and application, you'll see that this is the file which is created, and then you just have to move it to your application. That's it. Okay. So that means it is added to your system now. So that means it's similar that, okay, you just take this file, archive it and send it to any of your teammates. They don't have to go through big process here. So let's say I don't run this now. So I don't have another development Xcode here. So let's restart the Xcode bit to make sure it is there. Okay. And then once I go to editor, okay, 1 second, I need to launch it. Where it's code editor, right? Yes. Okay, thanks. Oh, it should be there. Yeah. So it's here. So you can directly run it without having to go through another Xcode now. Okay. Okay, I think I'm pretty much done with the content what I had today. Yeah. So any question and answers? Any questions? Mic? There's a mic. Yeah, I think for the question around how do we share it through DMG, right? Currently, there are some of the extensions which are not shared through App Store itself, right? But I'm not gone through in detail, but there is a tool called create DMG. So that way it will just create a DMG for you, and then you can share it through probably your FTP server as well. So that's what we have to try it out. I've not done it extensively. This is because I'm new to Mac application itself.
Because IPA and stuff requires Apple developer.
Yes.
And I tried that, but that was
yeah. So if you want to go through App Store itself, let's say distribution, then definitely you will need the app ID creation, validation, distribution, everything. Yeah. Because this did not require anything. This can just share the file. Similarly, it will create a DMG file and share it. It will just be an installation process.
Okay, sir. Thank you.
Any other questions?
Do we have any more questions? No? Okay. Then let's hear a round of applause for Pawan. Thank you, Pawan, for guiding us and making our editor smarter. Please scan this QR and give us feedback for today's event. This QR is for all the 3 sessions combined. Chalo, take out your phones. Scan. Are we done? I'll give you all a few, half a minute more. Do you want to candidly share how the session was and what we could have done better, or what you like the most about the session? Anyone wants to share? Voluntarily तो कोई नहीं करेगा. ठीक है, QR. Okay, till you all put your feedback in, I would like to call upon and welcome the Swift Bengaluru team. I'd like to call upon Gokul. There are wonderful partners which made the beautiful event happen. So over to you, Gokul.
Go for the next slide. Hi all. So it was great to meet you all today, and yeah, about Swift Bengaluru, we are a group of iOS developers or any other Apple platform developers. So we meet up once in every month, like in offline mode, and we try to organize like online meetups once in 2 months. So yeah, so every event, like what happens is every like knowledgeable person comes and they share their like expertise with the team. Yeah, and you can like follow us in Swift Bengaluru meetup page where we keep like everyone posted about our next events. Yeah, next one. Cool. And talking about the roadmap, so as I said, like we organize meetups every 1 month and then online meetups every 2 months. We have been like doing it for a while now,
And the other things that we are trying to do are like like open source projects, and then hackathon once a year, and like every other things. Yeah, next one. So this is our team behind Swift Bengaluru. And if you have any venue sponsors that are available, or if you want to talk in the next event, or like be part of the team, you can reach out to one of us. Yeah. Any questions? No, I guess. Yeah. Do reach out to us for venue sponsors, or if you want to talk in our next event. Yeah. Thank you. Thank you all. It was a great evening.
Thank you, Swift Bengaluru, and thank you, Gokul. Last but not the least, I would like to call upon Danish to wrap up this meetup. Danish has 12 plus years of expertise in iOS and web development, specializing in Swift, Objective-C, and Agile methodologies. And our beloved mobile track lead for Intuit India. Please bring your hands together for Danish.
Can you guys hear me? Perfect. So this has been a really great kickoff for the series of Intuit meetups that we are planning for mobile teams over here. I hope you guys found the sessions insightful and the discussion engaging, and the TA meetup that we had was quite valuable for you guys. Just to recap, can I get the email? Perfect, thank you. So a quick recap of for the meetup that we had today. We had Gen AI mobile technology and platforms, which we went through the renderers, the experiences, the multimodal inputs, and the derived context to build out a proper mobile development process and create engaging experiences. Then we had the interesting ML iOS applications by Swapnil, where we spoke about the native workflows using the Vision APIs to create smarter applications. That had the most interest. Thank you, Swapnil. Last, we had Pawan coming in for enhancing our Xcode with AI using custom editor extensions, which was really great to get started on using OpenAI or Claude, or whichever GPT model you guys want to use. So these topics provide quite an insight for us to go through and test out the AI capabilities in Xcode, build out great iOS applications. Going forward, a quick thank you. Sorry, I'm so sorry. There we go. A quick thank you for all the speakers. They had been amazing. We had Wasim, we had Swapnil and Pawan taking up different topics. So on behalf of Intuit, we would like to recognize you and give you a small token of appreciation. Can I have Swapnil and Pawan back on the stage? And do we have Diti over here? Two more minutes. Do you have Pawan? Perfect. Do you want to give it? You can give it.
No, please.
I have my hands. Yeah. Cool. Swapnil, can you please come on stage? Just a small token of appreciation for your time and effort. Pawan, please. Thank you. A big thank you to the organizing team. It took a village to get this done. This was the first meetup that we had at Intuit. We had our partners, which you saw just a few minutes ago. We had Nayan, Gokul, Abhishek, and Amit as our partners for the specific planning. Then we had the Intuit core team, which was basically Akashlal, our keynote speaker. Then we had our host, Ishika, and myself. They had Dhriti, Nancy. We had our branding and comms team who worked hard to make sure that we are socializing this event properly. We had our tech culture champions community, which is a broad team of your mobile, web, and other areas of the Intuit ecosystem. And our facilitators who made sure that we had proper screen sharings, the mics are working as expected, and no flaws over there. Last but not least, the Intuit leadership team, the Intuit India's leadership team, whose support helped shape this meetup. We had a lot of folks coming in from different companies over here, as you can see, which is great. So until next meetup, please continue coding, building out stuff, and we'll see you soon. Thank you. We're going to take a group picture. Please come on this side. We'll just move the chairs. Ajay, Bharat.